Okay, this video tutorial looks at the mathematical strand of functions and graphs, and more specifically, we're going to focus our understanding on domain and range. So what is a domain and what is a range? So basically a domain of a relation, all right, is the set of values that happen on the horizontal axis, which is usually the x, okay? So we can see in our diagram here, the domain is as far as we go along the x-axis. All right. And let's call, if we call this point AB, and we call this point up here CD, then the range would be, the domain would be from A to C. All right. The range, therefore, is the vertical displacement of the horizontal, the vertical axes. Okay, and then the range here would be B to D. Okay, because the range, we talk about the vertical movement, the domain is the horizontal amount. Okay. Now the way we talk about range and domain is we use notation, and in order to do this we can use a few different things. We can use something called set notation, all right, which is in our first column here. Okay, and that's how we're writing with things like greater than or equal than, so those kind of signs, in order to identify the bits on the graph. Remember, set notation can also include y's, not just x's. We might have interval notation, which is our next one, okay, here, all right, and we have number line graphs here, okay. Basically, all of these mean this, if we're looking at the first example, all right, so we're looking at the top row, the set of all x such that x is greater than or equal to 3. So all of those, the set notation, the interval notation, and the number line graph all mean the same thing. Okay, it's important to remember, like I've got a note just here. Okay, it's important to remember with number graphs, if it's hollow, it doesn't mean it means it doesn't include it. So here's an example where it's hollow. The dot is hollow on the 2, so it means it's less than 2, not less than or equal to. Whereas in our first example with the 3, it's actually solid, so it's greater than or equal to. So a solid means or equal to, a hollow means it doesn't. All right, so these are all different examples that we're going to use to try and write down or communicate our domain and range. So here's some examples. There was a car park charging problem that we looked at, and here's a graph for question 1 that talks about the prices. Okay, so the function is defined at all times, such as 0 is less than the time, which is less than or equal to 24. Okay, because it's about 24 hours. Okay, so the domain looks at the time. Okay, because the domain is again the horizontal axis. Okay, now the range looks like it's the y-axis, which is the money. Okay, so the range is about the money, so we're looking at the range. Okay, they're the different prices you'll pay, and the domain is looking at the different times. Again, in our second example, we've got a graph here, and it looks like there's a point, -1, -3. If we look at the domain to begin with, we know that everything, it looks like the arrow is pointing, everything is going to be positive along from -1. So it says here, all values of x are greater or equal to -1. If you look at the arrow, there's the solid point, okay, meaning equal to. So that they're the things that are included. So therefore the domain, all right, is x is greater or equal to -1. Because every x value along that graph is going to be greater or equal to -1. The range, okay, it looks like it's greater or equal to -3 because it's the graph, it's just going up in a straight line, it's not coming back down. All right, so the lowest point on that graph vertically is -3. So therefore, we can write y is greater or equal to -3. Here's some more examples. We can see here in example 3, All right, we've got a point that the vertex of this graph is 2, 1. All right, so we know that vertically everything has to be below 1. All right, the range is less than or equal to 1 because everything is below. So vertically we're looking at everything below 1. The x value says here, all right, x r means that x can be any real number. Now here, because it's along the x, these arrows mean that this graph just keeps going and going and going. We can basically say that x can take any value. All right, we don't have a set amount of values, or it doesn't have to be greater or equal to, or less than or equal to anything. It just can be anything, and hence why there's our domain. All right, but the range is everything less than 1, which is written here. In our last example, all right, we've got some asymptotes. Now, it's important to understand the vertical asymptote of x equals 2. So this is the vertical. Oops, spelled that wrong. Vertical asymptote, and this one is the horizontal. Now the graphs never touch these. They get really, really close, but they will never actually touch those vertical or horizontal asymptotes. So instead of saying it's greater than or equal to, or less than or equal to, we can basically say that it just doesn't equal those. All right. So you can see here the domain on the x is everything except for x equals 2. So that's why our domain, because it's along the x-axis or the horizontal axis, just says it doesn't equal 2. All right, and the y value is everything that doesn't equal 1. So we've got a range of everything except 1, because the graphs will never have a y value of 1. So here's a couple other examples. If we look at our first example of A, all right, we can see here that our range, our domains, we're looking at horizontal movement. We've got 8. So here's 8 horizontally. So we know that the graph literally just keeps going back this way. So that's why it has to be less than or equal to 8. Okay, because there's a solid dot here next to the 8. So we know horizontally the graph just goes to the left. So it's less than or equal to 8. Vertically, we have -2, and the graph just simply goes up. It never goes lower than -2. So hence why, that's where we get our y is greater or equal to -2. Okay. In our second example, if we're looking at B, we have a domain where, again, like one of our other examples, x can be anything, because the horizontal movement, okay, anything along here, x can equal, because these two arrows mean that this graph just keeps going and going and going and going and going. All right, but vertically we know that the graph literally is above this blue line. All right, and -1 is our y value, and that's where we get y being greater or equal to -1. Here's some more examples, okay, of stating the domain and the range for the following functions. Try and explain what's going on here. In A, we've got the square root of x take 5 is basically when x take 5 is greater or equal to 0. Okay, so therefore the function would be x is greater or equal to 5. Okay, and that's where it's written. Again, if we add 5 to both sides, we can treat this just as a normal equation, even though it's got a greater or equal sign, and then replace the equation back in, and we get x is greater or equal to 5. Okay. Since the square root can't be a negative, okay, then y has to be greater than 0, okay, because you can't have a negative number as a square root. You can't square root a negative number for this particular case. B, we're looking at B where it's got 1 over x take 5. Basically means that the bottom fraction, the denominator of this fraction, x take 5, can't equal 0. So therefore, x can't equal 0, and this would look like an inverse function. Okay, we've looked at these already. All right, so that should be fairly similar. Can't think of the word. That's okay. You've looked at it. So we know that it's going to give us one of these graphs. We've already looked at that as well. Familiar is the word. Fantastic. So basically, we know our domain here. Okay, anytime we get an inverse function graph, we kind of have a domain where x can't equal something. And remember that x can't equal the vertical asymptote, okay, which here in this case is 5. It looks like the horizontal asymptote would be 0 because it looks like it's our x-axis. Okay, so therefore, because y can't ever equal 0, 0 is the horizontal asymptote, and y therefore doesn't equal 0. Okay, in our last example, we've kind of combined the two top ones. So we know, again, this is an inverse function, but we also know that you can't have a y value of negative. We've talked about the square root, you can't be a negative, so this range comes down here again, all right, which means that we've only got one little bit in our graph. It's got to be above the x-axis. All right, we've still got our vertical asymptote at 5. We've still got our horizontal asymptote at 0. Okay, but we know that f of x has to always be a positive. All right, so therefore the range is in the y value, it's greater than 0, and in the x, it's got to be greater than 5. Okay, here are some practice questions. Please feel free to pause the video, and when you think you've got the answers, continue the video, and we'll see how you went. So let's have a look at our answers. So we're looking at A. Obviously, our domain for our x value is -1, and everything is positive from there, which is why x has to be greater or equal to, because we've got a solid dot, x equals -1. So greater or equal to -1. Our y value, we can see that our y value is 3, and everything on this graph is below 3. All right, so if we put a dotted line here, everything on the y value is below 3, which means that y has to be less than or equal to 3, which is why we end up with this section here. In our second example, we have a range where x is in between -1 and 5. So that's where we get the -1 and 5, because they're our x values. All right, and it's not equal to -1 because this is a hollow dot, but it could be equal to 5, hence why x is greater than -1 or less than or equal to 5. With our range on the same question, we've got 1 to 3. So here we've got y, 1 and 3, y being greater than 1 and less than or equal to 3. Okay, again here and here, given the hollow and the solid dots. In our last example, again, we've got an inverse function. So let's use orange. We know this is an inverse function because we recognize the graph. And again, remember, with an inverse function, the range is not so much what it is, but it's more what it isn't. All right, and looking at this, we've got our vertical asymptote at x equals 2, our horizontal one at -1. So these are lines that the graphs never cross. Therefore, our domain x can't equal 2, and our range y can't equal -1. All right, that's really important.